It's time for Maths with Mr. Thomas.
Are you ready? Then let's begin. Here we are with Chapter 7, Lesson number 3, Synthetic Division. So, what is synthetic division? Well, before we go on to that, I want to think first of all back to normal basic division that we've been doing for years, because there's certain words that you need to know the meaning of, such as quotient and remainder. Imagine if I gave you this here, this question, find the quotient and the remainder when 7,164 is divided by 5. Now you could probably go away and set that up no problem whatsoever. It would look something like that. And if you worked your way along from left to right, this is what you would end up with. So when we're dividing, this number here that we get out, the 1,432, is known as the quotient. And this number that is left over, you've been dealing with this for years, and that is your remainder. It's also worth noting that the number that we're dividing by is known as the divisor. So the three words that you need to know the meaning of, the divisor, the quotient, and the remainder, and you need to know which part of the division calculation they are. You could also reverse this as well. We've set it up as the division calculation, but you could reverse it and you could say that the 7,164 is equal to, well, you can see it's 5 lots of 1,432 plus that remainder that is left over. In other words, what we're really saying is that the original number is equal to the divisor times the quotient plus the remainder. Again, you need to know which part of the calculation they are. Why are we doing this? It seems really easy. Well, yes, you're right, it is. How could you make it more complicated? Connor, you're thinking you could put in bigger numbers. Well, yes, you could, but it wouldn't really make it any more complicated. It might just take you a little longer. Imagine if I gave you something like this. So now, let's try to divide 5x cubed plus 2x squared plus 8x minus 2 by x minus 2. And again, find the quotient and the remainder. Ryan, what are you thinking? I'm thinking, say what? I can understand, Ryan, because it looks really confusing. It looks really difficult. How are you meant to do this? Well, actually, it's really easy. It's really simple because we can use synthetic division to work it out. So, to do calculations like this that I just gave you on the last page, we use synthetic division. And synthetic division, it uses the nested form of the polynomial, and it sets this divisor, this thing we're dividing by, this x minus 2, equal to 0 to find the value left of the vertical line. Remember, when we set up our L shape, we need the number to the left of the vertical line. So I'm going to give you this in 4 steps. I've broken it down to make it try and quite simple to follow. So step 1, you draw the L shape and you write down the coefficients of the polynomial. After that, you set the divisor equal to 0, you solve it for x, and that is the value you write down to the left of the vertical line. You would then evaluate that using the nested form. You'd work your way along, in other words, divide, and once you've done that, it's dead easy to read off the quotient and the remainder. Again, once you've done that, what you could always do is you could reverse it and you could say that that original polynomial is equal to, well, the way you would find it is you would say is x minus that value to the left of the vertical line times by the quotient and then plus the remainder. What you can also say is that when we divide f of x by x minus h, the remainder, the way you get that is you can just evaluate f of h. So in other words, if we had x minus 2, well, the remainder when we're dividing by x minus 2 is just going to be f of 2. So we can just use substitution and evaluate the nested form just the way we did in the last lesson. I'll show you this through some examples. So, example number 1. Divide 5x cubed add 2x squared add 8x minus 2 by x minus 2. Step 1, draw the L shape and write down the coefficients. So, there's our L shape. The coefficients we've got 5, 2, 8 and negative 2. Just check we're not missing any x terms. We've got x cubed, then x squared, then x, and then just the number. So x to the power of 3, 2, 1, and 0. So that's fine. After that, set the divisor to 0 to find the value to the left of the vertical line. So we're dividing by x minus 2. So set that equal to 0, solve for x, badoink, and x would equal 2. So we write a 2 to the left of the vertical line. Step 3, divide. So we work our way along. Remember, you add the columns and then you multiply across by this number to the left of the vertical line. So add the columns. 5 add 0 gives us 5. Multiply across, so 2 times 5 gives us 10. Add the columns, that'll give us 12. Multiply across, we have 24. Add will give us 32. Multiply across gives us 64. And if you add the columns, again, you end up with 62. This number that we get out on the end, this 62, is the remainder. Remember, when we're dividing by x minus 2, the remainder will be f of 2, just using a substitution the way we did. So, because here we've got a 2, you can say that f of 2 is 62. In other words, that is your remainder. With these numbers here, 5, 12 and 32, these numbers are actually the coefficients of the quotient. How do you know though if that becomes 5x squared or 5x cubed or 5x to the power of 4 or just 5x? Well, what you do is you look at the original polynomial. Because here you've got a 5x cubed, you always take 1 off that first power. So 5x cubed, if you take 1 off the power, will be x squared. So that here is the coefficient of x squared. So the degree of the quotient is always 1 less than the original polynomial. So you can say then that the quotient is 5x squared. If that's an x squared, then that'll be an x, so it's plus 12x. And then that 32 is just going to be your constant, so it's plus 32. And the remainder is just the number that you get out on the end. So the remainder will be 62. That is the answer for that one. That is us dividing. We have the quotient and the remainder. If you were asked to take it a stage further, then you could always say that the original polynomial, remember, that's equal to x minus that number to the left of the vertical line, times by the quotient plus the remainder. So in this case, you would say that the 5x cubed and so on is equal to, well, to the left of the vertical line, you've got a 2, so it's x minus 2 times by the quotient, well, we just worked out that quotient, and then plus that remainder of 62. That's if you were asked for it. We're not in this case, but just in case anybody is interested. Example 2. Find the quotient and the remainder when x cubed add 6x squared add 3x minus 15 is divided by x plus 3. So first thing, set up the L shape and write down the coefficients. We have x cubed, x squared, x and numbers, so that's fine. We're not missing any x terms. So the coefficients, we have 1 x cubed, then 6, then 3, then negative 15. The divisor, we're dividing by x, add 3, so set that equal to 0. Solve that for x, and we find that x is negative 3. That, therefore, is the number to the left of the vertical line. Once we've done that, we divide. So, add the columns. So 1 add 0 is 1. Multiply across, so we're multiplying this time by negative 3, so negative 3 times 1 is negative 3. Add the columns, that'll give us 3. Multiply across gives us negative 9. Add the columns gives us negative 6. Multiply across, negative 3 times negative 6 gives us 18. And if we add the columns, we will end up with 3. Remember, this number that you get out is the remainder, so the remainder is going to be 3. Working out the quotient and the remainder then. So the quotient this time, well, because you've got the numbers 1, 3 and negative 6, remember they are the coefficients of this quotient. And because in the original polynomial, it's a polynomial of degree 3, if you take 1 off that power, you would end up with an x squared. So that is the coefficient of x squared. So we have 1x squared, then that'll be plus 3x, and then a minus 6. That will be your quotient. The remainder is the 3. Again, you're not asked for it, but if you wanted to take it a stage further, remember the polynomial is equal to its x minus that value to the left of the vertical line, which a lot of the time will just be this divisor, times by the quotient plus the remainder. So in this case, the original polynomial that we started off with is equal to x minus that negative 3, in other words x plus 3, times by the quotient, the x squared add 3x take 6, plus the remainder of 3. Example number 3. So for this one, let f of x equal 4x cubed, take away 7x squared plus 11. First of all, part A, divide f of x by x plus 2. Part B, express f of x in the form f of x equals x minus h times q of x plus r, where q of x is the quotient and r is the remainder. So although this looks worded, maybe looks a bit confusing, it's just asking you for the exact same thing that we've been doing. It's saying express the original polynomial in the form of x minus something times the quotient plus the remainder. So don't let the worded bits confuse you. So first of all, set the polynomial up in your L shape. So we've got 4x cubed, then we've got x squared, there's 0 x's, and then there's 11, so we'd have 4, negative 7, 0 and 11. Make sure you don't miss out the 0. No. From there, we're wanting to take the divisor, we're dividing by x plus 2, set that equal to 0, solve for x, and x is negative 2. This is the number to the left of the vertical line. Negative 2 goes in here. After that, you're wanting to add the columns, multiply across. So add the columns, we'd end up with a 4. Multiply negative 2 times 4, gives us a negative 8. Add the columns, we'd have negative 15. Multiply across, we end up with 30. Add, we end up still with 30. Multiply across, negative 2 times 30 is negative 60. And if you add to finish off, we'd end up with negative 49. Remember, this number that we get out is the remainder. That will then be negative 49. Another way of saying it is that f of negative 2, substituting in negative 2 here, would give us negative 49. Working this out then for the quotient and the remainder, we should really write that down because we're asked to express it in this form here. So we need the quotient and the remainder. So the quotient will be, well, have a look at these numbers at the bottom here. Because we're starting with an x cubed, take one off. It'll give us an x squared if you take 1 off the power, so that will therefore be 4x squared. Minus 15x, and then a plus 30. And the remainder is just this number on the end, so the remainder will be negative 49. Yes, it will. From there, part B, we're asked to express it in that form. Just remember that the polynomial, you can write it as x minus this value to the left of the vertical line, times by the quotient, plus the remainder. So in this case, we will say that f of x, because we're given f of x, that's the polynomial, that's equal to x minus negative 2, in other words x plus 2, times by the quotient, 4x squared, take 15x at 30, and then plus the remainder. The remainder is negative 49. So that is how you would do question 3. One more example. Example number 4. This time, let f of x equal 4x to the power of 4, add 3x cubed, take away 6x squared plus 3. Work out that divided by 2x minus 1, and then express f of x in the form 2x minus 1 times q of x plus r, where again q of x is the quotient and r is the remainder. Again, it's one of the worded questions, but don't let it put you off. It's really just asking for the same thing that we've been wanting in the other questions. So first of all, set it up with the L shape. So here, look for your coefficients. The x terms, we've got x to the power of 4, x to the power of 3, x to the power of 2. We don't have an x to the power of 1, in other words, just an x term. So we're going to have a 0x in there, and then we've got 3 in the end. So we'd have 4, 2, negative 6, 0x, and then the 3. We're dividing by 2x minus 1, so set the divisor equal to 0. 2x minus 1 equals 0. Solve that for x, add 1 to both sides, divide by 2, and x would equal 1/2. This is the number then to the left of the vertical line, so we put half in here. After that, just work your way along. So, if you have 4 add 0, it's still going to be 4. Multiply across, so a half times 4 will give us 2. Add the columns, gives us 4. Multiply across, we get 2. add, we get negative 4, multiply, half times negative 4 will be negative 2, add, we end up with negative 2, and a half times negative 2 gives us negative 1. Add the columns for the last time, and we end up with 2. We can then say that the remainder is going to be 2. In other words, f of a half this time, if you put a half in here, because we've got this half to the left of the vertical line, so f of a half will be 2. Once you've done that, remember, you can set it up and you can say the polynomial is equal to x minus the value to the left of the vertical line times by the quotient plus the remainder. So in this case, make sure you don't just write down 2x minus 1 times the quotient plus the remainder. It doesn't work when you have a number in front of the x here when you're dividing. So if your divisor has a number in front of the x, it doesn't always work. You'll notice for the other ones it does, but not in this case. So for this one here, we're going to set it up and say it's x minus the value to the left of the vertical line. In other words, x minus a half times by this 4x cubed, because that's x to the power of 4. Take 1 off the power, it'll give us an x cubed, so that's 4x cubed, then 4x squared minus 4x, and then minus 2. And the remainder is going to be 2. This is what we end up with. But if you look at this, we're asked to write it in the form of 2x minus 1 times by the quotient plus r. So how would you get that? How do we turn that into 2x minus 1? Well, looking at it, every single term here we can divide by 2. So in the brackets here, in this quotient, you could take out 2 as a common factor. So if you do that, leave the x minus a half as it is, take out 2 as a common factor here, it'll give us 2 times, half that to get 2, then 2, then 2, and then 1, and leave the plus 2 just as it is. So you're taking out 2 from every single term here and just putting it in front of the bracket. Instead then of multiplying it back out to go back the way, we could always multiply the 2 by everything in this bracket. So do the 2 times x and then the 2 times negative 1/2. And if you do that, you end up with 2x minus 1 times by the rest of it. So we'd have a 2x minus 1 times by the 2x cubed plus 2x squared minus 2x minus 1. And we've still got that remainder of plus 2. So that is setting it up in the form of 2x minus 1 times by something, the quotient, plus that remainder. That is how you do the ones when you have a number in front of the x in your divisor. Try some of these questions on your own. It is the Heinemann book, exercise 7c, page 135, using synthetic division to divide polynomials. Good luck, have fun. Bye! Woo!